Okay, so 7.1 was working with exponential functions. Okay, so 7.2, since we're in calculus, is going to be deriving them and then integrating them. Okay, so they start by kind of showing you this graph, and it's kind of an interesting idea, but they give you e to the x, so that is the equation that I drew there. Okay, so that exponential equation. The thing that's pretty interesting is if you were going to analyze the slope of that at any given spot, it actually would become its own derivative. Does that kind of make sense? So like, for example, if I was like going to show you the slope at each of these spots, so like when I'm over here, the slope is really flat, right? And so I'm going, oh, it's like really close to 0. And then the closer I move this way, right here, you'd be like, oh, what's the slope right there? 1, in fact, exactly 1. And then you continue on, and kind of the slope grows just like the function does. Does that make sense? So anyways, at the end of all this, believe it or not, the derivative of e to the x is exactly e to the x. Perfect, yeah, so not too bad. Okay, so, yeah, done. Okay, so if you look at the definitions between number 1 and number 2, so I kind of numbered them so that we can talk about them. But number 2, do you see how it's e to the u? So u is always like stuff. So if it was, for example, e to the 5x squared or something like that, okay, you would just be like, oh, the derivative is e to the 5x squared times the derivative of whatever 5x squared is. That makes sense? Kind of. Okay, so that's what the definition for number 2 is. It's just e to the u times the derivative of your exponential piece. Okay, so then they go a little bit further in. So number 3, now the base is different. So the base is a, so a being some constant number. So you could be like 2 is going to be the base 2 to the x. Okay, well, that's going to be 2 to the x times the natural log of 2. Yeah. Okay, and the reason that I highlighted number 4, like I started, is because if you didn't remember 1, 2, or 3, you could always use 4. So 4 is like the big one that you always can use. So any exponential equation, if you just know number 4, then you're good to go. Okay, so you have the exponential piece, you multiply by the derivative of the exponent, then you multiply by the natural log of the base. Got it? Oh, do you see what I wrote in blue right here? So for example, if you use definition number 4, e to the x, the derivative of e to the x would be e to the x times the derivative of x, which is 1, that's the parentheses, times the natural log of the base, which is e. What's the natural log of e? 1. So do you see how this right here is just the same as e to the x? So it's like a trick, or not a trick, it's a quick fix, I guess. All right, let's give it a try. You ready? Okay, so question number 1, we have e to the stuff. So which definition are we going to use? Number 2 is going to be the easiest one. We can use number 4, that would be fair game, but eventually we'll get to the part where we just have the natural log of base, or natural log of e, which we already talked about being 1. So, all right, so what is the derivative of that whole thing? So it starts out with just copying down exactly what is given. And then you just multiply by the derivative of the exponent. So what's the derivative of x squared minus 3x? Yeah. And then the last thing always in calculus is now you got to simplify it. How do you simplify that? Yeah, and really, there's no other way to actually simplify that. I mean, you could distribute the e through, but that would be pretty silly. Usually, you just never touch anything that has a quantity on it. So parentheses. All right, that was pretty fun. Okay, let's try number 2. Okay, so first of all, which definition? 1, 2, 3, or 4? Which one? That only is, you can only use 1 if the exponent is literally only x. So 2 or 4 would work. 4 always works, no matter what. So if you said 4 for all of these, you'd be correct. Okay. Okay, but 2 also works because the base is e. Okay, are you ready? Okay, so if we have e to the negative 3 over t, we start by literally copying it down. And then you just multiply by the derivative of the exponent. So anybody know what the derivative of, okay. Is it helpful that I maybe rewrite this as e to the negative 3? If I pull the t up, that would be t to the negative first power. That might be helpful for your brain. So when you derive that, what's the derivative of negative 3t to the negative 1? 3t to the negative 2. Okay, now that one you should probably rewrite because the t has a negative exponent, so the t has to get moved down. I prefer writing the 3 in front of any exponential piece, like a constant, over t squared. Okay. How do we do in that one?
That's awesome.
You guys' energy is so contagious.
I mean, how can you expect us not to get super riled up about this stuff?
I don't know. It's so fun. Okay, so for question number 3, since I have a radical, my first step is I'm going to rewrite it in exponential form. So would you agree that this is 3 to the v to the 1/2? Oh, that's bad too. All agreed? Okay, so which definition are we going to use to derive it?
Number 2. Oh.
4. This is, you have to use number 4 for this one because number 1, we have a base that's not an e, and we have an exponent that's not just x. We got stuff. Okay, so this has to be a number 4. All right, so how does it start? Copy it. And if you feel like you want to use the radical piece instead of the exponential, whatever floats your boat. Okay, then I multiply by the exponent, or the derivative of the exponent. So it's the derivative of v to the 1/2.
1/2.
The negative 1/2, good. And then I have to multiply by the natural log, wow, the natural log of the base. What is the base? 3. Okay, you ready for the simplifying of this one? Okay, so just think of a top and a bottom. Okay, anything that is in the top, so the 3 to the v to the 1/2, there is a natural log of 3 in the top. Okay, I like to write the natural log of 3 first. Always write the exponential piece last. Okay, do you see how there's a 2 in the bottom from the 1/2? 1 is on top technically, the 2 is on the bottom. So I say 2v to the 1/2. Top and bottom.
You should go back to the 2.
Go back to the 2. Where did I get the 2?
No, like.
Question number 2?
I'm good. I just want to make sure I wrote down right.
Oh, okay. All right, everybody good so far? Okay, so it's really not too bad. Oh, I guess I already started this one. Okay, so for question number 4, okay, we are going to, it says find the relative extrema. Okay, so when we're finding an extrema, what are we finding? Okay, good, a min or a max, which to do that, we've set the derivative equal to 0. So you can hopefully see already that I've written, this is going to require a product rule, right? First do second plus second do first. Okay, you ready? So I'm calling my first the negative x, my second is my e to the negative 2x squared. So first, negative x, d second. So I have e to the negative 2x squared. So if I'm deriving this one, which rule am I using? Number 2 has a base of e. Okay, so my derivative is, rewrite it, and multiply by the derivative of the exponent. So what is the derivative of negative 2x squared? Negative 4x. So that's a first d second plus second, so e to the negative 2x squared, d first. What's the derivative of negative x? Negative 1. Okay. So for me to simplify this, I have a negative x times a negative 4x on that first term. So what is negative x times negative 4x? 4x squared with my e to the negative 2x squared. And then on my second term, I have that times the negative 1. I'm just going to say minus e to the negative 2x squared. And I would call that good. Oh, that's right. Silly me. And then we have to set that equal to 0. Oh, this is where we get exciting. Okay. So, ooh, how do we do this?
Your calculator.
Oh, it says do not. How do you feel about pulling out a greatest common factor?
Oh, hey, that's pretty cool. Yeah.
So do you see how they both have an e to the negative 2x in them? So I'm going to pull that out like a greatest common factor. Okay, so what would be left of the first term? 4x squared. And the second term, minus 1. Good. Okay, so if I factored it, how do I keep going? Set each of them equal to 0. So this is kind of like going back to, ooh, do you remember how to solve exponential equations? Does anybody remember how to do the Shroop? Shroop? Yeah. Yes. No? Let's see. I feel like I'm surprised we haven't done this already. Or I feel like this will be in the next
There's like one
section. Oh, really? Should I just show it to you and I'll... Okay, yeah. Okay, so exponential form. So if you have a base to some exponent equals y, that's equal to the log of that base of y equals x. So when I say Shroop, I always think of it like it goes left to right to go into your conversion if you always have the base. So the log of your base of y equals x.
Or you can think that when it's in log form, that it squishes the
Yeah.
y out.
Yeah. So at the end of the way, we go start with the base, e to the x equals y. Anyways, because this particular base has a base of what? E. So Kale said, oh, it's just a natural log. Because you guys all remember, I'm sure, all natural logs have a base of e. So you can say natural log of 0 equals negative 2x squared. Anybody know what the natural log of 0 is? Nope.
0.
Nope. Nope.
Error.
Yeah. Can't do it. Impossible. You can never take a natural log or any kind of log of 0 or a negative number.
Wow, fun fact.
Fun fact, you'll need to know that. So anyways, this whole equation is a no solution on this one. The other way you could have thought of it is if you didn't remember that shrooping fact is you could kind of just say, okay, well, e to what power would equal 0? Okay, like, is it possible to have an e or any number with an exponent and make it turn into 0? No. So if you think of it exponentially, hopefully you might have gotten to the same spot. E to the nothing will equal 0. Yeah, not possible. Okay, but we got that other one. All right, how would we solve the 4x squared minus 1? So add 1, then what? Divide by 4, and then what? Square root it. So eventually, at the end of all of this, we get a plus or minus 1/2. Okay, so we still have to decide if that's a min or a max. And so in order to find a min or a max, or decide if it is a min or a max, we need a number line, right? Okay, so we're using this piece for this number line. Okay, so I need a number that's less than negative 1/2. Negative 1. Okay, so you ready for this? We plug in negative 1. Okay, so the first part I have e. Do you remember what negative exponent's going to do? Into the bottom. Okay, so it's not going to make it negative. It just puts it in the bottom. It makes the fraction small. Okay, so if I have e or 1 over e to the 2, e to the 2, e squared, is that a positive or a negative number? Positive. So the first piece is positive. Now if I plug 1 into the second quantity, that would be 4 minus 1. Positive. So get a positive, positive. Everybody follow that? Ish. Okay. What if I plug in a number between negative 1/2 and positive 1/2, such as 0? Okay. E to the 0 is 1. That's positive. So we have a positive on the first. If I plug 0 into the second, 0 minus 1 is a negative. And hopefully you realize that if I plug in a number greater than 1/2, like 1, that should be exactly the same as when you plugged in negative 1, because both pieces are squared, right? So we should get a positive. So up, down, up. So what's happening at negative 1/2? There is a max. So a max at the point, ooh, super. So what do we have to do to find the corresponding y value? Ooh, okay, so, I'm just going to leave this like this. I'm going to be a little lazy here and go. If I plug in negative 1/2, we're going to have negative 1/2, which makes positive 1/2, e. And then if I plug negative 1/2 into the exponent, that's going to make 1/4 times 2, 1/2. Yeah, we're just going to leave it like that for today. Okay, and so the min is going to be at the positive 1/2, and basically get the same answer, but the negative version. Okay, how do we do with that one? Loving exponents so far? All right, well, since we now know how to derive, second half is integrating. Okay, so I numbered them again. Apparently I missed the number 2. Okay, but basically these are corresponding directly to the last 4 definitions. Okay, so if the derivative of e is e, no, I said that wrong. If the derivative of e to the x is e to the x, the integral of e to the x is e to the x plus c, good. Okay, now for number 2, remember that if I had e to the u, the derivative was e to the u times the derivative of the u. Okay, so if I go backwards, what am I going to have to do differently this time? Divide by the u prime. Now, when you look at this notation, does that say to you divide by the derivative piece? No, I don't think it does either. Okay. So that's why I literally wrote the words divide by the u prime right there. Okay, so you're always dividing by the derivative of the exponential piece. Okay, and then on number 4, before we were multiplying by the natural log of the base, now we have to undo it and divide by it. Okay, ready? So undoing. Okay, here we go. Ooh, we just had to add in the integral piece. Okay. Okay. So for this one, okay, remember that this little piece is the piece that we're waiting for to cancel out. Okay, it's like the derivative of our prime, or u prime. Okay, so we're going to start by integrating this 4 to the x squared minus 1. Okay, so we're waiting. This is our u prime. It's the hook-on factor, as they call it. Okay, so if I integrate, I start with my 4 to the x squared minus 1. Okay, then what would I do? Close, not multiply, divide, because we're undoing derivative. When we derived, we multiplied, but when we integrate, we divide by it. So we're going to divide by the derivative of the exponent. So the derivative is 2x. And then we also have to divide by the natural log of the base. So what's my base? 4. Okay, so remember that x that was hanging there? I'm going to put it back in there because I'm waiting for that to cancel with the u prime from before. Okay, so do we have a cancellation? We do. So remember that this only works if that cancels out, with the x's cancel out. It's okay to have extra constants hanging out, but the x's have to cancel. Okay, we need to add a plus c at the end of it before I forget. Okay, so if we simplify this, oh, I don't want a plus c, excuse me. We have a defined integral from 1/2 to 0. I'm hoping those are going to be nice numbers. Okay. It seems rude to me, but okay, so I'm just going to rewrite this. So, okay, so we're just going to do the old top minus bottom, and we're not going to simplify. How do you feel about that? Okay. I'm going to write this one way and see if you guys follow what I'm doing. You see how they both, like, I have the 2 natural log of 4 in the denominator. What I'm going to do is I'm going to pull it out like a greatest common factor. It just makes things look a little nicer. You see, like this. Okay, you don't have to do that. It just makes me feel better, to be honest with you. So then I could go 1/2, and now I can do a top minus bottom. So 4 to the 1/2 squared minus 1 minus 4 to the 0 squared minus 1. Does everybody follow that like algebra? Okay, now on a test, I circle this and I'm done. Right? Do we want to practice simplifying that further, or we feel okay about it? Good? You like me to keep going? Oh, chugging. I thought you meant like cheap chugging with my simplification. Okay. So we're good there. Okay. Okay. So let's try number 6. Okay. So the first thing that I'm going to do for question number 6, this is pretty icky looking. Hopefully you're looking at this and going, ew. I kind of did too. Okay, so the first thing I'm going to do is I'm going to rewrite this. For starters, I have a 3 on the bottom. Okay, so kind of the same way I played that bottom piece and pulled it away, I'm going to do the same thing with this one. Okay, so first I'm going to pull the 1/3 away. Okay, then I have my exponential piece, my e to the 2 over x. And then I'm also going to pull my x squared upstairs. Okay, because right now we don't have a rule of integration that works with fractions. Okay, so I'm going to call this x to the -2 dx. Is everybody okay with the rewrite? Okay. So now the reason that I want to do that and pull that x to the -2 up is because this piece right here, just like in the last example, is going to be my hook-on factor that I'm looking for to cancel. Okay. All right, so I'm going to integrate this e to the 2 over x. Is it also helpful if I rewrite this as If I have 2 over x, that's the same as 2x to the negative first. You decide whatever works for your brain. Okay, so I got the 1/3 way out front. Okay, we're going to integrate the exponential piece. So ready for it? Okay, so I rewrite it. E to the 2x to the negative first. What do I have to divide by? The derivative of the e's exponent. So what is the derivative of 2x to the negative first? Negative 2x to the negative first. Or negative, no, let me try the negative second. Thank you. Yeah. Okay, what else do I have to divide by? Okay, natural log of base of e, which technically do we need to say the natural log of base of e because what's that equal to? 1. Yes, it is. Okay, and then remember that I have this u prime. That's what I'm waiting for to cancel out. Okay, so did it cancel out? Can I use this reverse chain rule? Yes, it worked. Love it. Okay, so now I'm just going to rewrite it so my answer looks nice. I'm going to squish this fraction together. I have on the top, I have 2, nope, that's an e, excuse me, 2, oh my god, I can't say it again, e to the 2 over x, or if you feel better about calling it x to the negative first. And then what's going to be in the bottom? Negative 6. Because you have the 1/3 in the front.
I forgot about the 1/3.
Yeah. And don't forget plus c because we don't have a definite integral this time. How do we do on that one? Did that one make a little more sense? It's kind of clicking with that reverse chain piece.
Alright, let's do it.
Woo! You guys, I starred this one. Oh, it's actually not too bad. Good news. Good news. Okay. All right, so first thing that I want to do, because it's written as a fraction, is I'm going to rewrite it, right? Okay, watch how I rewrite this. E to the x minus e to the negative x, group it, times e to the x plus e to the negative x, notice those are the same, to the negative 4th power dx. Okay, so remember, I have 2 quantities, but which one is going to be the one that I'm going to call my new prime? The first one, good, the one without the exponent. So this piece right here, I'm going to use a red, this piece right here, that's my u prime. That's the piece that I'm waiting to cancel. Okay, ready?
So, like, if they were flipped, would it still be the same thing?
They were flipped. Are you meaning top and bottom flip?
Yeah.
Then if it was flipped, then this like complete flip, this would be to the negative first power, and then we to the positive first power.
Yeah, but would your u prime still be the same?
I don't think it would work out. I think it would not be integratable with the reverse chain. Okay, so I'm going to wait with my hook on piece and I'll write it at the very end. So I'm going to start with my quantity to the negative 4th. Okay, so remember that that's a reverse chain because we have a quantity to the negative 4th. Okay, so remember on a reverse chain, we add 1 to the exponent and divide by it, and then divide by the derivative of the inside. Okay, so if I add 1 to the exponent, what does that give me? Negative 3. And then I have to divide by negative 3. And divide by the derivative of the inside piece. Okay, so I have an e to the x. What is the derivative of e to the x? E to the x. Good. Okay, and what is the derivative of e to the negative x? It is, did you follow the y?
Multiplied
By the derivative of the exponent, negative 1. negative e to the negative x. Everybody okay with that? That makes sense? Okay. So then remember now I'm just going to write on this hook-on factor that I didn't write yet. The u prime. Okay. So did that cancel? It did. So if I rewrite this, ooh, I have a negative exponent. So what's going to be in the top? 1. Good. And then everything else is moving downstairs. And then to the positive third. And don't forget, plus c. It's hard to forget that, or hard to remember after all of that.
Alright.
Okay, we good?